Today we are going to see this daily temperature problem. Let's begin. So we are given an array of integer and we want to return an array of integer, right? And so basically we're returning the indices in an array of integer temperature. This represents a temperature like this, like this. So what do we want to do? We basically want to return array of integer where for the ith day, meaning if we are at the index 1, how many days do we need to wait before we get a warm temperature? So we are at 73. So this is our, let's say this is our 0th day, this is our one. If we are 0th day, meaning today is 73 degree. If tomorrow is 74 degree, how many days do we need to wait? We need to wait 1 day. Let's say tomorrow comes in, and let's assume this as tomorrow. So let's say we are at the first day, right? First, this is a little bit confusing, but anyways, so this is we are at the first day. How many days do we need to wait before we get a warm temperature? So I said we need to just wait 1 day, one more day. That is just 1 day, right? And let's say we are at this day, second day. How many days do we need to wait before we see a warm temperature? We need to wait 1, 2, 3, 4. To wait 4 days. So at 4 days, how many days we need to wait? We need to wait 0, and then here also we need to wait 0. Is this true? Yeah, this is true. So the default answer is we need to integer. We need to initialize it to 0. If there's no answer, then it's a default of 0. So what we'll do? We'll do a new array and we'll fill it up with 0, right? Like this, okay? To the length of the given array. This is as the temperature. And so what will be our logic? Basically, I cannot calculate anything until I compare it with some other day, right? Basically, if I am at the first day, I need to wait till tomorrow or till the warm temperature comes in so that I can calculate how many days I have to wait. So that's the main logic, okay? So I can see it as a stack problem. Why? Because today is on solved, we put it on the stack, and then if we see a warm temperature tomorrow, we take it out, we calculate it, and then we resolve it towards the answer. Let's say it's warm today, tomorrow is not that warm, tomorrow is cold, then we take tomorrow and stack on the top of today's calculation, because we haven't seen a warmer day. And now let's say third day comes in where the temperature is warmer, then we calculate, we resolve it for it. So it's a stack problem. Why stack? PROB problem. Why? We cannot resolve the answer just by looking at today's temperature. We need to wait till the next day where the temp rises, right? And what we want to do? Temperature is less than the stack top, meaning whatever we are storing that has not yet been calculated. We take it out and calculate. We take it out and calculate. So this is what we are going to do. So now let's build from this logic. We have our array. Let result equals new array. And we have temperatures dot length, and default we're going to initialize it to fill with 0, because if there is no date further that is warmer, then we will just be using 0, right? So this is what, and then as I say, we'll be using stack. We'll initialize this to stack. And now how does stack work? We basically iterate through our data and basically compare with it the top of the stack. Either we take an item from the stack or we put it in the stack if we need to resolve it later on. So for let I equals to 0, I is less than, this is what we can do. We can start from the first second index, because we don't know just by looking at the first index, that is 0th index, we cannot resolve the answer for that. So we'll say stack.push the temperature. So we need to compare the temperature between 2 days. Let's just use the index in this case. So let's see index that is 0. Okay, we'll put the index 0, and we will start from index 1. Temperature temperature dot length, and I increases. Okay, and so this is what I'm gonna check if the temperature, sorry, if the temperature at the top of the stack is given by um, stack dot length -1. If the temperature at the top of the stack um, is less than the current temperature, given by the I, meaning we push we push 0 on the stack. So we are now at this point. And we check if the temperature today is greater than yesterday. If it is, then we know we can resolve for the yesterday's value. Um, Else, what we're gonna do? We're gonna push. Let's say if this value was 72, then we enter into the else statement, because 72 is less than 72 is not greater than 73. We enter into this else statement, and at this point, even today's temperature is not resolved, because we haven't seen a higher temperature than today. So what we will do, we'll also put it into the stack. So that at this point, we will push it like 0 and then 1. And at this, let's say the next state comes in. At this point, we see 75 is greater than the top of the stack, which is 172, and we resolve for this day, and then we'll also resolve for the day before. Okay. So else, this is what we're gonna do. Else, basically, we have push it into the stack. Stack dot push the I. This is what we're gonna do. This is not the right idea, because uh, if the temperature yesterday, let's say we are at this day, right? If the temperature yesterday was lesser than today, we resolve for the yesterday, and also we'll need to check for the day before that, which is also in the stack. So if I just use if, it won't solve like that. So I'll need to use while here. While temperature stack at the top is less than temperature given today, we will resolve it, we'll compute for it, and then else we'll just push the today's temperature, because today is not resolved unless we see a higher temperature tomorrow. Calculate the indexes and store in the answer. So for example, our result at the index that is yesterday. So at this, we need to return what? We need to return 1, right? So basically, result at the stack at this. Basically, this is the top of the stack. That means yesterday. We store a value of what? We store a value of today, which is given by I minus the index. This is given by, again, this. So if we are at this position, then what do? We look it in the output code, right? So 75 is greater than 72. We resolve for this value, which is 1. That is 2 minus 1 is 1. And now we solve it for that, right? That means we say stack dot pop. And once we pop that, what we have is this. Now we check if the top of the stack, that is 0 index, is less than today's temperature, which is 75. Yes, 73 is less than 75. So we again say the top of the stack, and that is given by 0. Result at index 0, which is this, equals to I, which is 2 right now. This minus the stack length is 0. So stack top is 0. So this becomes 2 now. So this is how we are going to work. And the I updates eventually, and we simply return the result. And we can also simplify this, right? When we are accessing the stack top, and we are doing the same thing. Let's just say constant previous index equals to given by this, and then we just use previous index I minus previous index. And so basically stack dot top. So this has to be stack dot pop. Let's see. Now let's accept that. And that's how you solve it. So this is a stack problem. Why? Because whenever we are standing at a given temperature at a given day, we cannot solve it, because we need to check it with something else, and that something else is only the tomorrow's data, tomorrow's temperature, right? So that's why we have a stack of something that is unsolved, and once we have a higher temperature, we pop it out from the top of the stack. So that's why it's a stack problem. Let's now talk about the time complexity. Time complexity is basically O of n. Why is and what is n? N is basically the length of the temperature, because the while loop only executes when there is a pop in the stack, and this does not decrease, like, increase the time complexity. And space complexity is basically we're creating a new array, so which is again O of n. And at the worst case, we might push all the elements from the starting to the end until we find them high temperature at the end. And so that is also O of n. So O of n plus O of n is 2n, and this is also going to be O of n.